Capacity. Capacity is how much data your RAM can hold at one time. Think of it as working space for your computer. When you open a program, the computer copies the files it needs from your storage drive into RAM because RAM is much faster to access. Common sizes are 8 GB, 16 GB, 32 GB, and 64 GB. More capacity means you can run more programs simultaneously without your computer slowing down. It does not make individual programs run faster. When you run out of RAM, your computer starts using your storage drive as backup memory, which is called swapping or using a page file. Storage drives are much slower than RAM, so when this happens, you'll notice stuttering, freezing, or programs taking a long time to respond. For basic use like web browsing and simple office work, 8 GB is enough. For gaming and general productivity tasks, 16 GB is the sweet spot. For heavy workloads like video editing, 3D rendering, or running virtual machines, you'll want 32 GB or more. One common misconception: unused RAM is not wasted RAM. Your operating system actively uses available RAM to make your computer run smoother by keeping frequently used files ready to access. DDR. DDR stands for double data rate. It means the memory sends data twice per clock cycle, on both the rising and falling edges of the electrical signal. This doubles the amount of data transferred compared to older single data rate memory. Each DDR generation is physically and electrically different from the others. DDR4 and DDR5 use different voltages, different signal speeds, and different internal designs. Your motherboard supports only one DDR generation. You cannot use DDR5 RAM in a DDR4 motherboard, and you cannot use DDR4 RAM in a DDR5 motherboard. The physical notch on the bottom of the RAM stick is in a different position for each generation, so you literally cannot insert the wrong generation into your motherboard slots. Each new generation brings improvements. Speeds get higher, power efficiency improves, and new features get added. Speed. RAM speed represents how many data transfers happen per second. You'll see two terms used: megahertz and megatransfers per second. The RAM's internal clock actually runs at a certain megahertz speed, but because of the double data rate technology, it transfers data twice per clock cycle. So the effective transfer rate, measured in megatransfers per second, is double the actual clock speed. A stick rated at 3200 megatransfers per second has an internal clock running at 1600 megahertz. The number on the RAM packaging is the megatransfers per second value, which is what matters for performance. For DDR4, common speeds are 3200 or 3600. For DDR5, common speeds start at 4800 and go up to 6400 or higher. Faster RAM helps most with CPU-intensive tasks, games running at high frame rates or low resolutions, and systems using integrated graphics. Integrated graphics share your system RAM instead of having dedicated video memory, so they benefit significantly from faster RAM. There are diminishing returns with RAM speed. Going from 2400 to 3200 makes a noticeable difference. Going from 3200 to 4000 makes a much smaller difference. The performance gains get smaller as speeds increase. Similar to going from a 60 to 144 Hz monitor, you definitely notice it, but going from 240 to 360 Hz, barely noticeable. Your RAM speed is limited by two things: your CPU's memory controller and your motherboard support. Both must support the speed you want to run. If your CPU only supports up to 3200, then even if you install 4000 speed RAM, it will only run at 3200. Channel. A memory channel is a data pathway between your CPU and RAM. Single channel means one RAM stick installed. Dual channel means two matched RAM sticks installed in the correct slots. You can have the same total capacity in single channel or dual channel, but dual channel provides double the bandwidth. For example, one 16 GB stick gives you single channel, two 8 GB sticks give you dual channel with the same 16 GB total, but with twice the data transfer bandwidth. The performance benefits are real. In games, you'll see higher frame rates and smoother gameplay. The biggest benefit shows up in what's called 1% lows, which are the minimum frame rates during gameplay. Higher 1% lows mean less stuttering and a smoother experience. Systems with integrated graphics see massive improvements from dual channel because the integrated GPU is fighting for the same memory bandwidth as the CPU. Always use two sticks when possible. Install them in the correct slots, usually the second and fourth slots on a 4-slot motherboard. Check your motherboard manual to confirm which slots enable dual channel. Timings. RAM timings measure how long the RAM waits before responding to a command. These are measured in clock cycles. When your CPU asks for data, there's a small delay before the RAM starts sending it. That delay is what timings measure. CAS latency, written as CL, is the most important timing number. It represents the delay between when the memory controller requests data and when the RAM starts delivering it. Lower CL numbers mean faster response. CL16 is faster than CL18. CL30 is faster than CL36. Speed and timings work together to determine actual performance. You need to consider both. A 3200 speed kit with CL16 timings might perform similarly to a 3600 speed kit with CL22 timings because the higher speed is offset by the slower timings. You'll see timings listed as a sequence of 4 numbers like 16, 18, 18, 38. The first number is CAS latency. The other 3 represent other delay measurements inside the RAM, but CAS latency is what matters most for comparing RAM kits. For most users, timings make a small difference compared to speed and capacity. For everyday use and even regular gaming, the difference between CL16 and CL18 at the same speed is barely noticeable. XMP or EXPO. XMP and EXPO are pre-made performance profiles stored directly on your RAM sticks. Without enabling these profiles, your RAM will not run at the speed you paid for. All RAM has a base speed set by the industry standard called JEDEC. For DDR4, that base speed is 2133. For DDR5, it's 4800. When you first install RAM, it runs at this slow base speed even if you bought 3600 or 6000 speed RAM. The faster speeds are technically overclocked speeds, and you must enable the profile to unlock them. XMP stands for Extreme Memory Profile and was created by Intel. EXPO stands for Extended Profiles for Overclocking and was created by AMD for DDR5. They do the same thing, but use different standards. Enabling the profile in your motherboard BIOS automatically sets the correct speed, timings, and voltage all at once. The manufacturer has already tested these settings extensively, so they're safe and stable. This is not optional if you want to use the speed you paid for. If you buy 36,000 speed RAM and never enable XMP, your RAM runs at 2133, and you've wasted your money. The process is simple. Restart your computer, enter the BIOS, find the XMP or EXPO setting, enable it, save, and exit. Your RAM will now run at full speed. Form factor. Form factor is the physical size and shape of the RAM stick. DIMM stands for Dual Inline Memory Module and is the full-size RAM used in desktop computers. SO-DIMM stands for Small Outline Dual Inline Memory Module and is the smaller version used in laptops. SO-DIMM is about half the length of a regular DIMM. Laptops use SO-DIMM because of space constraints. Some very small desktop cases, like mini ITX builds or compact PCs, also use SO-DIMM to save space. These are not interchangeable. Desktop motherboards have DIMM slots. Laptop motherboards have SO-DIMM slots. When buying RAM, make sure you're getting the correct form factor for your system. Voltage. Voltage is the electrical potential supplied to the RAM. Standard DDR4 runs at 1.2 volts. When you enable XMP on DDR4, it typically increases to 1.35 volts. DDR5 runs at around 1.1 volts standard. Higher voltage allows the RAM to run at higher speeds and tighter timings. This is handled automatically when you enable XMP or EXPO. For the average user, voltage is not something you need to worry about. It's relevant mainly for stability when overclocking or for enthusiasts manually tuning their RAM for maximum performance.